All right, Algebra 2, this is going to be a nice, just short little review of factoring by grouping. You've seen this before, you know how to do this, so we're just going to review it. So I can factor polynomials using the grouping method, and once you see it, you'll know what I'm talking about. So the first thing, we've got a little review. We're going to factor if possible. If not, we'll write non-factorable. So the first thing we always look for is the greatest common factor. In this one, x squared minus 3x minus 4. There is no greatest common factor. So we'll see what it can factor into. I've got a -4, so it multiplies to -4, and it adds to give me -3. So I've got a 4 and a 1 multiplied to 4. And since this is a negative sign, I know that my 4 has to be negative. So that's going to factor into x minus 4, x plus 1. Oops. There we go. The next one, 3x squared plus 12. Remember, greatest common factor. I see that I can divide both these terms by 3. So I'll pull my 3 out front, and I'm left with an x squared minus 12 divided by 3 is 4. And then I happen to notice this is a special polynomial. It is the difference of perfect squares. So I can factor it further into 3 times x plus 2, x minus 2. And I'm done with that one. And the last one for review here, 3x squared minus 6x plus 3. Again, we're going to look for the GCF, the greatest common factor, and I see that each of these are divisible by 3. So I'm going to take a 3 out front, and I'm left with x squared. 6 divided by 3 is going to give me a -2x. 3 divided by 3 is going to give me a positive 1, and we'll see if that is factorable. Let's see, I've got a -1 and a -1 add up to give me -2, so I can factor that further. So I'm going to keep my 3 out front, and I've got x minus 1 times x minus 1, and that'll multiply out to give me my original polynomial. So here's Dory's list on how to factor. First, we need to have a polynomial. So if it is a polynomial, we're going to look for the greatest common factor. And then there's some different steps that we would take from there. So we'll find a greatest common factor, and then we can go this route, factor the product of binomials if it's a binomial. See if it is a special product. If it is a special product, it's either going to be the difference of squares, it is going to be a perfect square trinomial, or as we learned in the last lesson, it could be the difference or sum of perfect cubes. I'm just going to put difference of perfect cube. So we learned that in the last lesson, so that's another special product. After we find the GCF, if it's not one of the ones that we've talked about already, either it is not factorable, or we can factor by grouping. So that's what we're going to talk about today, is factoring by grouping. Factoring by grouping is exactly like what we do when we do the AC split. So it's going to look very familiar for you. We're going to have 4 terms. So if you end up getting a polynomial that has 4 terms, you're going to want to factor by grouping. So they've already done the hard work for us. All we need to group or do is group our terms together. Remember, you want to keep, if there's a negative sign out front or a positive, you want to keep that sign inside the parentheses, and then we're going to take the greatest common factor out. So when I look at my first term here, I've got 9x cubed plus 18x squared. I see that I can take a 9 out of both of these terms, and I can take 2 x's out of both of these terms. So I'm going to take a 9x squared out, and I'm left with an x plus 2. I don't have any x's left for that, but if I were to multiply that back out, I would get 9x cubed plus 18x squared. In these next two terms, negative 4x minus 8, I can take out a negative 4. And then I'm just left with an x. Negative 4 times a positive 2 gives me a negative 8. So now we notice exactly like when we did our factoring in the last unit, I've got a plus 2 in both of these. So I'm going to pull my x plus 2 out front, and that's going to be multiplied by these two terms. So I've got a 9x squared minus 4. Now I'm not quite done yet because I happen to notice that second binomial, those are both perfect squares. So in this guy here, 9 is a perfect square, x squared is a perfect square, and 4 is a perfect square. So I'm going to keep my x plus 2. And then this factors into a 3x plus 2, 3x minus 2. Now we are factored all the way down. We can't go any further than that. So noticing the difference of squares is huge. When you're doing these, that should almost become second nature, noticing if it is a difference of squares. And for that to happen, it must be subtraction. So let's do a few more examples. We're gonna group our first two terms and our second two terms and pull out the greatest common factor out of each. So in this first one, I've got 3x cubed minus 12x squared. I can take a 3x squared out, and I'm left with an x minus 3 times 4 is going to give me 12. And in my next set here, I've got a 2x minus 8. All I can take out is a plus 2. And I'm left with an x. Positive 2 times negative 4 is going to give me 8. And check it out. It's exactly what we wanted to happen. It was to get the exact same terms there. So we can pull that one out front. X minus 4. And that's being multiplied by 3x squared plus 2. And there's nothing else I can do with my 3x squared plus 2. So we're just going to leave that one alone. Again, group our first terms, group our second terms, keeping that negative sign with the 9x. And then pull out the greatest common factor. So I get, let's see what color we want. I get x cubed minus 5x squared. I can take out an x squared out of each of these. X squared, I'm left with an x minus 5. If I were to multiply all that out again, I would get x cubed minus 5x squared. And then in my second two, I got a negative 9x and a 45. So I can take out a negative 9, and I'm left with an x. Minus a minus is going to give me a positive, so this turns to minus. 9 times 5 is going to give me 45. So I notice I've got an x minus 5 and an x minus 5, exactly what we were hoping for. So we can take our x minus 5 out front and then put these two guys together. Get an x squared minus 9. And what do you notice about that? Hopefully we caught that one. I've got the difference of squares, so I can factor that farther. X minus 5, and then this factors down into x plus 3, x minus 3. And we would be done from there. Couple more just to practice with. So we're going to group our first two terms, group our second two terms, again keeping that negative inside. And I've got a 16x cubed minus 48. Let's see, does 16 go into 48? 48 divided by 16 equals 3. So I'm left with a 3 left. So I can take a 16x squared out, and I would be left with an x minus 3. So that's how 3 times 16 is going to give me 48. And then negative x plus 3, I need to take out a negative 1 out of that guy. And I'm left with an x, a positive x now. And a negative times a negative is going to give me a positive 3. So I need a negative 3 here. I've got x minus 3, x minus 3. So I can put these two guys together. Pull my x minus 3 out front. And I've got 16x squared minus 1. And I happen to notice 16 is a perfect square, x squared is a perfect square, and 1 is a perfect square. Difference of squares again. So I have x minus 3. And then I have 4x plus 1 and 4x minus 1. I just take the square root of each one of those and make one a plus and one a minus. And the last example I've got for you, we're going to group these, group those, and pull out the greatest common factor. So I've got 2x cubed minus 12x squared. Again, I can take out a 2x squared, and I'm left with an x. 2 times 6 is going to give me 12, so I get a minus 6. And then my second one, I've got 5x minus 30. It looks like I can take out a 5 out of that guy, so a plus 5, and I'm left with an x. And 6 times 5 gives me 30, so x minus 6. Again, I notice I have an x minus 6 in both of those. So I'm going to put these two together and pull that x minus 6 out front. X minus 6, and I'm left with a 2x squared plus 5. And it doesn't look like we can do anything much more with that. And so that would be our answer. Hopefully that was a fun little review. Factoring by grouping is one of my favorite ways to factor. So let me know if you have any questions at all.